Before we get to the Q&A, we've got Jason Casselman, who's my colleague with the Canola Council of Canada. Jason is an agronomy specialist with the Canola Council and is the team lead on precision agriculture, plant establishment, and profitability. Here's Jason.
Thanks very much, Jay. And so thanks for, this is our final webinar in our series for the Canola Watch Webinars. And it's great to be with everyone here today. Cass, could I get the next slide, please? So our crop production and innovation team includes 10 agronomy specialists located throughout Western Canada. And we're focused on those areas of ensuring sustainable and a growing supply of canola. Each of the team has unique strengths related to research, leadership, coordination, knowledge creation, and transfer, and preparing for emerging threats and supporting regulatory and market access efforts. Next slide. Our objective of the topic of making every plant count for the Canola Watch webinar is to promote key areas in the best management practices that will help Canadian canola farmers in Western Canada increase productivity and move towards the industry's 2025 goal of 26 million tons of production and an average yield of 52 bushels per acre. Next slide. So with the Canola Council, we do have 5 agronomic priorities for canola. And right now they're using 4R nutrient management practices, choosing the best seed traits for each field, achieving that uniform 5 to 8 plants per square foot, identifying and managing the top yield robbers, and harvesting all seeds and delivering them at #1 grade. Next slide. The #3 priority is to achieve a uniform 5 to 8 plants per square foot, and the canola plant population target of 5 to 8 plants per square foot is a safe target to balance yield potential and economics. Canola Council of Canada research found that stands of 5 to 6 plants per square foot yielded about 5 bushels per acre more than stands that averaged 2 to 3 plants per square foot. Meta-analysis conclusion was that canola farmers seeking to maximize returns should target populations greater than 5 plants per square foot, and the plant populations lower than this will almost always have yield loss. Since canola plants in a low population density grow larger and branch more, they tend to mature later, and those secondary branches account for up to 80% of the yield for canola crops with only 2 plants per square foot. Those plants will have a wide range of maturity, creating yield and quality losses, and simply due to the inability of time to align with all plants and harvest limitations. Those extra branching in very thin stands can delay seed maturity up to 21 days, depending on environmental conditions. CanolaCounts.ca is an online crowdsourcing tool to help growers, agronomists, and crop scouts drive the adoption of plant establishment assessments while tracking progress towards the canola industry production goals. Agronomy recommendations are often based on probabilities, but practice is most likely to achieve the desired outcome. This is important to note because canola crops with a thin stem can yield fairly well in certain circumstances. Canola is often called a flexible or plastic crop because individual plants can adjust the number of size of branches and pods they produce in response to additional moisture, light, and nutrients. As a result, canola has a famous ability to compensate for a bad start, as long as it does get that long season and clear sailing along the way. The challenge with a thin stand is that those plants will be bigger and with more yield coming from those side branches and more time for that crop to be harvest ready. That lower seeding rate or lower emergence percentages, canola fields can also be patchy, and this will further reduce yield potential and increase management challenge. And a crop with bulb patches and plants with different growing stages is a big challenge to optimize for spraying and harvest timing. Next slide. So uniformity across the field will lead to consistent canola growth stage timing and will help with planning and executing field operations like pesticide applications and harvest. By taking regular plant counts, growers and agronomists can identify challenges and implement changes such as optimizing seeding rates and speeds to achieve that uniform 5 to 8 plants per square foot in future seasons. For remote counting, the Canola Council ran a Canola Counts citizen science program in 2021. Reflective of the challenging spring for some farms, emergence percentages ranged from below 20% to over 90%. Yet while emergence rate was low to average, most fields had a stand of that 5 to 8 plants per square foot. Canola Council will run that Canola Counts program again this spring, and please go to canolacounts.ca to enter your counts. I encourage growers to take steps ahead of the seeding season to implement a plant stand strategy and work to improve emergence that will pay dividends throughout the growing season. Canola stands with enough plants that emerge evenly across the whole field have the best chance of realizing yield goals. And these stands are the most efficient at utilizing applied resources and provide the best return on investment. While seeding, growers need to monitor field conditions and check seeding performance at soil conditions as soil conditions change from field to field or in different areas in the same field. Prepare to adjust that seeding equipment to achieve the end goal of a competitive high-yielding crop. Next slide. The number 4 priority is to identify and manage those top yield robbers in each field. Integrated pest management challenges include disease, weeds, and insects, and the economic thresholds exist for each of those pests, and the implementation forms a backbone of an integrated pest management plan. Next slide. Phosphorus fertilizer should be side-banded when high rates are needed. This can be done with a combination of seed row placement at safe rates and a sideband or spring band placement, as it is better to apply phosphate fertilizer in the soil at a time when the crop can access it early in its growth cycle. This is a conclusion from Jessica Pratchler and Stuart Brandt's Enhancing Canola Production with Improved Phosphorus Fertilizer Management Study. The Pratchler study also found that foliar phosphorus applications are not a good alternative to seed-placed applications unless the field is known to be highly deficient, in that less than 10 plant parts per million of phosphorus in the top 6 inches of soil, and no other applications are made. Patrick Mulecki's study of reducing toxicity of seed-placed fertilizer in canola found that damage from seed-placed phosphorus can be reduced by increasing the width of single shoot openers from 1 inch to 4 inch and using a narrower row spacing, 9 inches instead of 12 inches, which increases seedbed utilization. Next slide. With the ever-increasing yield potential of newer canola hybrids, phosphate nutrition in this crop is crucial to ensure that yield potential is optimized. Researchers Jessica Pratchler and Stuart Brandt from the Northeast Agricultural Research Foundation found that predicting the degree of damage caused by seed-placed fertilizer is very difficult, as it is influenced by other factors such as soil texture, soil organic matter, and moisture. And since these factors vary considerably across most fields, damage can be quite variable across the various landscape positions. Furthermore, even adding a small amount of ammonium sulfate to phosphorus in the seed row can increase damage to seeds and reduce canola emergence. Therefore, this practice should be discouraged. Overall, researchers found no evidence better responses associated with seed-placed phosphorus over sideband, even at low rates, and that high rates of sidebanded phosphorus are always equal to or greater than seed-placed. And this was true for stand establishment and yield. Yield improved with high phosphates rates in general, and in some cases were found to be even greater with sideband treatments, especially at higher rates. Optimum canola yields were reached between that 70 and 80 pounds of fertilizer phosphorus. Therefore, if rates of phosphorus required, fertilizer phosphorus should be sidebanded to minimize seed damage and maximize yields, as it is the most consistent and beneficial application method due to minimize seed damage and high plant populations achieved as a result of sidebanding, providing the added benefit of reduced days to maturity, which will lower green seed risk. Levels of plant available phosphorus are drifting lower in many fields in Western Canada, and this hidden hunger will be hurting yields. Phosphorus rates that at least match crop removal are necessary to maintain soil productivity. Next slide. Seed row placement is best for the first 15 to 20 pounds per acre of phosphate, as it may improve emergence and seedling vigor on deficient or cool soils where availability is reduced. Larissa Grenko with the University of Manitoba presented research on seed-placed phosphorus and sulfur fertilizers and the effect on the canola plant stand and yield based on the findings led by Cynthia Grant of AAFC Brandon, where evaluated improved practices for phosphorus, sulfur, and nitrogen management in canola, found that applying phosphorus and sulfur fertilizers in a blend increased the frequency and severity of damage with plant stands, reduction by as much as 57% and an average of 18% overall. The high ammonium sulfate blends caused the most damage, resulting in an overall average plant stand reduction near 20%. As for yield, the greatest and most consistent yield increase resulted from the combination of a high phosphorus, low ammonium sulfate treatment. However, due to a high salt index, seed row applications that include ammonium sulfate does come with a high risk of ammonium toxicity. Grenko concluded that in order to maximize the benefits and minimize the risks of applying highly available phosphorus and sulfur, farmers with a single shoot, low seedbed utilization seeding equipment should reserve the limited tolerance of canola for seed row fertilizer to phosphorus. Next slide. Plant counts help quantify the success of canola stand establishment in a given field. Multiple counts averaged across a field will give an average plant density for that field, which can be compared to the target plant density and emergence percentage. The average number or percentage of seedlings that have grown out of the number of plants seeded this spring. Understanding that each field's plant density and emergence percentage, the average number of seedlings that have grown out of the number of seeds planted this spring will help management decisions in that field that season and will identify areas for improvement for future seasons. Enter plant counts from your canola field at canolacounts.ca, the crowdsourced survey. Next slide. For all methods of counting plants, several counts per field are required to get a good representative average plant density and emergence percentage. The average number of seedlings that have grown out of the number of seeds planted this spring. If emergence is patchy, dig up those parts of those seed rows to look for non-germinated or non-emerged seeds and plan to return and reassess. If canola density and staging is not uniform throughout the whole field or in patches, make note of those areas and investigate the cause. Dry soil, frost may be difficult to avoid, but plants stunted or lost because of poor seed placement, fertilizer placement, or fertilizer rates, and surface residue can serve as an indication of a weakness in the stand establishment system. Monitoring fields should start 10 days after seeding, and if conditions are good, 15 days if conditions are cool. If plant stand is lower than expected for the given seeding rate, seeding size, and estimated seeding survival, check equipment settings, seed characteristics, and field conditions to identify why ideal plant population was not achieved. The cause or causes may relate to the seeding operation, such as inconsistent depth, excessive fertilizer placement, seed or mechanical issues, and frost or wind or flooding, insects or disease, or herbicide residue also being factors. When stands are spotty and thin, careful management is required to preserve the surviving plants. More conservative thresholds may be warranted for insects, weeds, and diseases. Next slide. Research shows that there is plenty of potential to improve yields by customizing our approaches to soil zones, disease management, insect pressure, and weather. And the key to growth is providing the best agronomic information and advice for each unique farm operation based on the latest science. We believe that there are yield gains that can be achieved by implementing 5 agronomic priorities on farm, and this will help growers achieve the industry goal of 52 bushels per acre. Next slide. The Canola Council has several resources available online, including Canola Encyclopedia, Canola Research Hub, Canola Digest. And please sign up for the Canola Watch, free, unbiased, timely, and research-focused newsletter. Thanks very much, Dave, for helping put together the Canola Watch series, and open it up for questions.